In this video, I'm going to show you how we can solve an equation for one variable in terms of others. Many formulas in the science involve several variables, and it is usually necessary to express one variable in terms of the others. Look at the first example here. PV equals nRT. We are given this formula and we are asked to solve this equation for R. So we want to find R. R is the unknown that we want to find in terms of the other variables that here we have. For finding R, we notice that we have to get rid of this n and t from the right side of the equation. How we can get rid of n and t? By dividing this equation, by dividing both sides of this equation by nt. Simply we can find R in terms of the other variables. The reason that we divide both sides by nt is that we want to solve this equation for R. So we want to get rid of this n and t here. To get rid of n and t, we divide both sides by nt. Then we have PV over nt equals R. So R is equal to this. So we solve the equation for R. Attention, n with n cancels, t with t cancels, and we have R in the right side. So R equals PV over nt. This process that we used here for solving the equation for R is similar to solving a simple equation like this. For example, suppose you want to solve this simple equation, 4x equals 12. If you want to solve this equation for x, what you have to do? You have to get rid of this 4, this coefficient of x. How we can get rid of 4? By dividing both sides by 4. Then 4 with 4 cancels and x is 12 over 4. We used a similar process for solving this equation. Now look at the next example. V to the 2 is given V0 to the 2, V initial to the 2 plus 2AD. This is a formula from kinematics in physics. And in this formula, we want to solve the equation for A. Attention, the unknown A that we are looking for is here. First thing that here we have to do is to move this extra term to the left. Then, similar to the previous question, we have to get rid of this 2 and d here. But before dividing this equation by 2 and d, first we have to move the v0 to the 2 to the left. If we move v0 to the 2 to the left, then we have v to the 2 minus v0 to the 2 is equal to 2ad. Before we divide both sides of this equation by 2d to get rid of these 2 and d here, it's a good idea to rewrite this equation in the form of 2ad is equal to v2 minus v0 to the 2. The reason that it's a good idea to rewrite this equation in this form, attention, nothing is changed in the equation. Just we write this expression in the left and we write this expression in the right side. The reason that this is a good thing to do for solving equation is that usually we prefer to have our unknown in the left and other variables in the other side. So for that reason, I prefer to write the equation in this format first. Then we divide both sides of this equation by 2d. If we divide left side and the right side by 2d, 2 with 2, d with d cancels, and then we have a equals v to the 2 minus v0 to the 2 over 2d. So a, which is the unknown here, and basically it shows the acceleration, is v to the 2 minus v0 to the 2 over 2d. Now look at this example. V, which shows the volume, is given 1/3 pi r to the 2h. and we want to solve the equation for r. To find r from this equation, we have to get rid of 1/3, pi, and h. First, I try to get rid of that 1/3. How we can get rid of 1/3? It's easy. We have to multiply both sides of this equation, both sides of the equation by 3, reciprocal of 1/3. When you have 1/3 and you want to get rid of 1/3, simply multiply both sides by 3. The other way that you can get rid of 3 is to do a cross multiplication. If you multiply this 3 by v, then you have 3v is equal to this. The result at the end is the same. So, first we try to get rid of 1/3. We multiply both sides of this equation by 3. By multiplying both sides of this equation by 3, we have 3v equals pi r to the 2h. Attention, we multiplied left side by 3. We multiplied right side by 3. 3 with 1/3 cancels. We have pi r to the 2h, and in the left we have 3v. Now, we have to find r from this new equation that here we have. So we want to solve this equation for r. To find r, we can divide both sides by pi and h. But before that, again I prefer to write this equation in the form of pi r to the 2h equals 3v. Attention, this equation is the original equation, but we rewrote it in this format because we prefer the unknown to be in the left. But this is completely optional and it's not necessary to do this. If we divide both sides by pi h, if we divide the left side and the right side by pi h, pi with pi, h with h cancels, and then we have r to the 2 is equal to 3v over pi h. Now from this equation, if we take a square root from both sides, r is a square root of 3v over pi h. Usually when we take a square root from a quadratic equation like this, we have to put a plus minus here. And you can put plus minus also here. But because we know that this formula shows the volume of an object and r is the radius, we know that radius of a circle or radius cannot be negative, so we only consider the positive sign for the radical. But if we don't know anything about r, then we have to put a plus minus here for the radical. But because r shows the radius, we don't need to put plus minus sign for the radical. So r is radical 3v over pi h. Look at this equation. V to the 2, which v is velocity, is given v initial or v0 to the 2 plus 2ad. Here, we want to solve this equation for v0. For finding v0 here, we know that to find v0, we have to take a square root. But before that, first we have to move this to the left. Then we take a square root for finding v0. v2 minus 2ad is equal to v0 to the 2. Then, from this equation, if we take a square root from both sides, then a square root of v to the 2 minus 2ad is v0. But attention here, v shows v0 is the initial velocity. And initial velocity can be positive or negative, because velocity is a vector and it can be positive or negative. So, it's good idea to put a plus minus for the radical. So v0 is plus minus radical v to the 2 minus 2ad. Again, attention, it's better to write your answer in this form. v0 is plus minus. Always write the unknown that you are finding in the left and the answer in the right. So v0 is plus minus radical v2 minus 2ad. Now look at this example. F is given, which F shows the force, is given Gmm over R to the 2. This formula shows the force between two objects. But here our focus is on solving the equation. And we want to solve this equation for M. And M is here in numerator. To find M, the first thing that maybe you want to do is to get rid of this R to the 2 here, because we don't like to work with fractions. So first thing that you can do is to multiply both sides of this equation by R to the 2. If we multiply left side and right side by R to the 2, we can get rid of R to the 2 in the denominator. So basically we can eliminate the denominator. Or the other way that you can get rid of R to the 2, you can do a cross multiplication. Let me remind you, cross multiplication, whenever we have a fraction equals another fraction, you can multiply D by A or B by C. Here we can multiply R to the 2 by F. So one way for solving this equation is to multiply both sides by R to the 2 or do a cross multiplication. Then we have FR to the 2 is GMM. Then it should be easy for you to find M. The M that we are looking for is FR to the 2 over GM. To find M from this equation, basically we divide left side and the right side by GM. G with G cancels, M with M cancels, and so the unknown that we are looking for is this. So M is this expression, FR to the 2 over GM. And this is the answer of the equation. The other way that maybe you want to solve this equation for M is to consider or rewrite basically this equation in this format. F is given originally as G times M over R to the 2. If you pay attention, this is a coefficient for M. This is also a coefficient for M. And this R to the 2 is also a coefficient for M. But this coefficient is in the denominator. Look at this, for example, 2/3 x. This 2 is multiplied by x, but this 3 is also a coefficient of x. So here, G, M, and R to the 2, all of these are coefficient of the unknown that we are looking for. So I prefer to rewrite this equation in this format. G, M over R to the 2, all of this is coefficient for M. Attention, this is the original equation. GMM over R to the 2 over R to the 2. But I rewrite the equation in this format. Now it is clear that this is coefficient for the unknown that we are looking for. Let me remind you how we solve equation like this. 2 over 3x equals, let's say, 10. To find x, simply we multiply 3 by 10 and we divide by 2. So x is 3 times 10 divided by 2. Or in another word, we move this denominator to numerator. We multiply this by numerator and we divide by this. So denominator goes to numerator, numerator goes to denominator. If we do same thing for this, what is M? Then M would be F, this goes to numerator, FR2 over GM. And this goes from numerator to denominator, like a cross multiplication. Now look at this example. F is given GMM over R to the 2, again same formula. And we want to solve it for R or radius. To find the R from this equation, the problem that here we have is that the radius or R that we are looking for is in the denominator. Consider this example. Suppose you want to solve this equation. 4 equals 5 over x. What you do here? Simply you multiply 4 by x and then you solve it for x. Do the same thing here. Attention, when we solve for an unknown, these are like numbers. You should not be confused by letters. Those are numbers, like the numbers. Behave them like a number. So for finding r, the first thing that we do is we multiply both sides by r to the 2. By multiplying both sides by r to the 2, we have fr2 is equal to gmm. We multiply left side by r to the 2. We multiply right side by r to the 2. r2 and r2 cancels. We have this, and in the left we have fr to the 2. Now, for finding r from this equation, we have this coefficient for r. Attention, r is the unknown and everything other than r is a number. So this is like a number. So we want to get rid of this number. How we can eliminate f? With dividing both sides by f. So r to the 2 is g m over f. And finally r is a square root of g m over f. And this is the answer for r. And you don't need to put plus minus here because r shows the radius or the distance between the two objects, between the two mass, and distance or radius is positive, so we don't need to put plus minus for the radical. Now look at these equations. We are given d, which is distance, equals 1/2 at to the 2 plus v initial t, and we want to solve this equation for a. This is a famous equation in kinematics. The unknown that we are looking for is here. So this is like a number. What we do with numbers? We move them to the other side. When we want to find unknown, we move the extra numbers to the other side. And we keep the unknown in one side. So we move v0t to the left. Then we have, by moving v0t to the left, we have d minus 1/2 d minus v0t is equal to 1/2 at to the 2. The unknown is here, but this is coefficient for the unknown, and this is also the coefficient. How we can get rid of 1/2? Simply by multiplying both sides by 2. So we multiply both sides by 2. If we multiply both sides by 2, then we have 2d minus 2v0t is equal to at2. So we multiply everything here by 2. And we multiply this also by 2. But 2 with 1/2 cancel, and we have this. Finally, what is a from this equation? If we divide both sides by t to the 2, then a, which is acceleration, is this. So by dividing both sides by t to the 2, acceleration, or a, is equal to 2d minus 2v0t over t to the 2. This is the value of a in terms of other variables. Now look at this question. Same formula is given, but we want to solve it for t. And this is a little different question, because if you notice, the t that we are looking for is here and is also here. And if you pay attention, we have t to the 2 and t to the 1. This should remind you a quadratic equation, because we have t to the 2 like x to the 2 and t to the 1 like x. So we have an equation that in the equation we have the unknown to the power of 1 and the unknown to the power of 2. And this is like a quadratic equation. How we solve quadratic equations? If you remember, the general method for solving equation like this, ax to the 2 plus bx plus c equals 0, The general formula was negative b plus minus radical b to the 2 minus 4ac over 2a. This was the famous quadratic formula that we use for solving quadratic equations. And we need this formula for solving this equation for t. Now, for finding t, first we have to rewrite it in this format. So we have to move everything to one side and the other side should be 0. Then we can use this formula. So to make the other side 0, simply move this d to the right. Then you have this expression minus d equals 0. Because when we move d to the right, nothing is left in the left, so the left side is 0. So we have, by moving everything to the right, we have 1/2 at to the 2 plus v0t minus d equals 0. Now you can use this formula for finding t, but we don't like to have a fraction here, because then you have to plug in that fraction here and it makes the calculation a little more difficult. So how we can get rid of that 1/2? By multiplying this equation by 2. So we multiply everything in the left and everything in the right by 2. The right side is 0, so 0 times 2 is 0. But if we multiply every term in the left by 2, we have this at to the 2 plus 2v0t minus 2d equals 0. We multiply this term by 2. 2 with 1/2 cancels. We have this. 2 times this is this term. 2 times d is this term. Now we can use the quadratic formula for finding t. T equals negative b. What is b here? This is b basically. b times x, b times t. T is x here. So negative b is negative 2v0 plus minus radical b2, or 2v0 to the 2. 2v0 to the power of 2 minus 4 times a, which is a here, times by c, which is this expression, times by negative 2d, all over 2a. 2 times this, 2a. This is the answer for t, for the time. But it's a good idea to simplify this answer if it is possible. But this is completely optional. The question was solve the equation for t, and we did. But we want to simplify the answer. In numerator we have negative 2v0 plus minus radical 2v0 to the 2 is 4v0 to the 2. Negative 4a times negative 2d is plus 8ad over 2a. Now, if you look at the inside of the radical, you can see that we can factor 4 from these two coefficients. So, if we factor 4, we have negative 2v0 plus minus radical plus minus radical 4 times v0 to the 2 plus 2ad. Because we factored 4, 8 divided by 4 is 2, all over 2a. Now attention, we have 4, which is a perfect square. A square root of 4 is 2, so we can move this 4 to the outside of the radical. So let me erase 4 from here, and instead of that I put a 2 here. Now look at the numerator. This term has a 2. This term also has a 2. So we can factor 2 from this term and this term, and we can cancel that 2 with the 2 in the denominator. So please attention, because both of the terms in numerator have these 2 as a common factor, we can factor that 2 and we can cancel that factor with 2 in the denominator. If we do that, then these two, and these two cancels. So attention, from these two terms we have to factor a 2. Then inside the bracket we have negative v0 plus minus radical v0 to the 2 plus 2ad. Then we cancel basically these two which is outside with these two. This is what's happening here. So what is the final answer for t? T is negative v0 plus minus radical v0 to the 2 plus 2ad over a. And this bracket for this expression is not necessary anymore because we don't have any coefficient here, so it's better not to put any bracket for that expression. And this is the answer for t. I hope by watching this video now you have learned about solving equation for one variable in terms of others. If this video was helpful for you, please subscribe in my channel and see you in the next videos.